polynomial which is denoted by t3x for this function x times e raised to negative 4x center at a equals 0. So the formula for degree 3 Taylor polynomial would be the constant, the very first one, c naught, then c1 x minus a, but a is 0, the center is 0, so c1 x plus c2 x is squared, so degree 3 means we go up to cube, right, c3 x cubed. And where these coefficients are found by the formula, cn's are, we find the nth derivative of the function. For c naught, it would be 0th derivative. Evaluate at the center, which is 0, and divide by n factorial. Okay, so in this case, we need to find 4 constants. So let's make a table where we take n in the first column. So like n c naught, so n equals 0, 1, 2, 3. Then let's find the derivative of the function. So nth derivative of the function. Let me put a little bit more room there. And evaluate this at the center, which is 0. It will be a number. And then based on that, we divide by n factorial to get the corresponding cn. So cn in the fourth. Okay, so n equals 0 means 0th derivative of the function. So 0th derivative means the function itself. So x e to the negative 4x. Okay, now let's evaluate this function at 0. So simply plug in x equals 0. So 0 times 1 will be 0. And cn would be c0, right, in the first one. So c0 would be this number divided by 0 factorial. So 0 factorial is just simply 0. So we have 0. Then 1 means we need to find its derivative. So let me find the derivative. It needs some work here. So derivative of this one, let's find over here separately. So we got x e to the negative 4x. When we find the derivative, it's a product rule. Okay, it's a product, so we need to use the product rule. Like f g means f prime g plus g prime f. So here, derivative of x is 1 plus derivative of e to the negative 4x is e to the negative 4x times derivative of negative 4x is negative 4. So derivative of second factor times x. So we can simplify by factoring e to the negative 4x out. Okay, that leaves what? 1 here, negative 4x there. So that goes here in our case. So when n equals 1 means first derivative, let me write down this. N f1, 1 means first derivative of this one we found here. E to the negative 4x, 1 minus 4x. Now evaluate this derivative at 0. So replace x by 0, e to the 0, 1 times 1 minus 0, 1. So this will be 1. So c1 would be this 1 divided by 1 factorial. 1 factorial is also 1, so this is simply 1. Okay, so this is c naught, because n equals 0, c naught, c1. We need to find c2 and c3. Okay, and then we go back and we write, so let me erase this one. So let's find derivative of this. Okay, this 2 means second derivative means derivative of this one. Okay, derivative of this one would be, again, it's a product of two functions. So we must use the product rule. Derivative of first factor is negative 4 e to the negative 4x. Okay, you can, like here, times second, 1 minus 4x, plus derivative of second factor, 1 minus 4x means 0 minus 4, okay, just negative 4, times first. First is e raised to negative 4x. We can simplify by factoring e raised to negative 4x out. Okay, that leaves negative 4, 1 minus 4x here. Okay, negative 4, let me put negative 4 out as well. So just 1 minus 4x, and then plus, there is nothing left because everything's out, so 1. Okay, let me clean this up and then write again. So after we find the derivative, we can factor, we can simplify. So negative 4 e to the negative 4x out. So 1 minus 4x, and then everything's out, so plus 1. So 1 plus 1, 2. So this is negative 4 e to the negative 4x, and inside is 1 plus 1, 2 minus 4x. Evaluate this at 0. So 4 times e raised to 0, 1, negative 4 times 2. So this will be negative 8. And C2, so negative 8 divided by 2 factorial. 2 factorial is 2, so this is negative 4. And finally, we need to find 3. Means now find the derivative of this one more time. So we need to find this derivative of this one. Okay, so let's find the derivative using the product rule again. So let me write here. So I got negative 4 e to the negative 4x times 1 plus 1, that was 2 minus 4x, and we want to find its derivative. Here is a product. So negative 4 we can pull all the way outside. Now we can think as a product. Derivative of first factor is negative 4 e to the negative 4x, leave second alone, plus derivative of second factor is 0 minus 4, negative 4 times first. I pull the negative 4 outside. And we can simplify negative 4, we can pull outside and multiply with negative 4, so that's positive 16 e to the negative 4x outside. So 2 minus 4x plus everything's outside 1. So this is 3 minus 4x. Okay, so we go back and write this down. Derivative of this one comes out to be 16 e raised to negative 4x. 2 plus 1, 3 minus 4x. These are kind of in the pattern. Look, 1, negative 4. So if we multiply this by negative 4, we get this one. Multiply by negative 4, we get this one. And inside 1, 2, 3. I mean, if we need, we can easily find next derivative. Now we evaluate this at 0, at the center. So that will be 16 times 1 times 3, so 48. And this is 3, right? So C3, we divide by 3 factorial. So 48 divided by 3 factorial. What is 3 factorial, by the way? 3 factorial is 3 times 2 times 1, the 6. So 48 divided by 6 is 8. 48 divided by 3 factorial. So we got C0, C1, C2, C3. And after we plug these numbers here in the degree 3 Taylor polynomial, we have the final answer. So thus, the degree 3 Taylor polynomial is, so we can write down the final answer. C0 x, C0 was 1. Hold on, what is C0? Okay, that was 0, my bad. So 0, then we got 1. So let me write here, okay. So C0 plus C1x plus C2x squared plus C3x cubed. C0 is 0, so nothing. This was 1, so 1x. C2 was found to be negative 4, negative 4x squared. And this was 8 plus 8x cubed. Okay, I mean that's the final answer. 1, negative 4, 8. And what we did here is basically we are approximating this curve by this degree 3 polynomial, okay, near a equals 0.